Alright, in this last video in Chapter 11, we'll look at things called phase diagrams. Phase diagrams are a graphic representation of the equilibrium between the solid, liquids, and gas of a substance. It's a graph, and the graph on the vertical axis is the pressure that substance is undergoing, and on the horizontal axis it's its temperature. And it's split into three distinct areas because there's three phases. On the far left-hand side, lowest temperature, usually the lowest pressure areas, or up to the highest pressure areas, is the solid. And the solid has the most compact or closest together particles. So particles are stuck together and they just vibrate. Then the liquid, which is still a condensed phase of matter, but the particles are free to flow past one another and they might be a little bit further apart. And then we have the gaseous phase of matter, which of course are just crazy far apart and have the most energy, and that's the furthest to the right. Let's take a look at some phase diagrams that are in your textbook because they have much more vivid pictures or diagrams of what they would look like. This is a phase diagram for a pure substance right here, where notice they have solid labeled in kind of a greenish color. And then the line that separates the solid and liquid is the melting or the freezing point. And you could actually drop it down here and then you could find the temperature of that solid-liquid interface, and then you'd know the freezing point or the melting point. And then you can see the liquid phase right here ends at a point called the critical point. And this is the critical temperature and the critical pressure of that substance, where no amount of pressure would take this substance and make it be a liquid anymore. It will be what's called a supercritical fluid past then. And it takes on some special characteristics. But this critical point then could be measured as a temperature and as a pressure. This red line right here is the difference between the liquid and the gas, and the phase change there, of course, would be vaporization, or going the other way, condensation. And you could find the boiling point at a particular pressure by finding where the pressure meets this line, and then drop it down and you know the temperature of that as well. This special point where the line splits is called the triple point, and this is the place where solid, liquid, and gas are all in equilibrium. All three phases of matter can be found at the same time. And then the line going down here back down to zero is the interface between solid and gas. Sublimation would occur this way, deposition would occur this way, and so it would be the solid-gas interface, which you'd see a lot on something like solid carbon dioxide, dry ice, where it goes directly from the solid to a gas. This is the phase diagram for a substance called water, and water, you can see, actually has just a slight tilt to the line right here between the solid and the liquid, because remember, water is one of the few things that's a tiny bit more dense in its liquid phase than its solid phase, and it shows that just a little bit because it's a tiny bit more condensed right in here. But you can find that at 1 atmosphere of pressure, if you slide it along right here, this line right here should drop down and it should be close to 0, because 0 degrees at 1 atmosphere is the freezing point. And then if you follow this line over to the red one right here, you should be able to drop this down, and it's going to be a little bit difficult to see because it's not great, but it should be at 100 degrees Celsius, because at standard atmospheric pressure, the changing from liquid to gas, known as boiling, happens to occur where the atmospheric pressure is equal to the vapor pressure, and that's at 100 degrees Celsius. Now, if you lowered the pressure and got down here, then you'd find that boiling point is decreased or depressed, and it's much lower. You can see the triple point of water is a pretty low Celsius right here, a little bit above 0, and the atmospheric pressure is quite low, 0.0063 atmospheric pressure, and that's where you can see solid, liquid, and gaseous water at the same time. And then you can find the critical point right here, where no amount of pressure would cause water to be in the liquid phase anymore, above 374 degrees Celsius. Here's one more phase diagram. This phase diagram happens to be for methane, CH4, and then it asks us a bunch of questions about it and asks us to read some things about it and be able to interpret that diagram. So we'll take just a couple of seconds to try a couple of those questions. I'm actually going to turn the diagram this way a little bit to give us a little bit wider view of it, so then we can read the questions at the same time, and then we'll zoom in on it so it gets just a little bit bigger as well. So it says, first of all here, use the phase diagram for methane to answer the questions. What are the approximate temperature and pressure of the critical point? So the first thing it asks for is the critical point, temperature and pressure. So the critical point would be right up here at 3, because that's where above this we can't put any more pressure on it to make it be a liquid anymore. And if you drop it down from here, it looks like it would be at about -80 degrees Celsius or so. And then if you bring it over here, it looks like it would be above 10, but not quite at 100. So maybe maybe about 50 atmospheres or so, maybe 60 atmospheres, something like that. So that would be the critical point location. Second question, what are the approximate temperature and pressure of the triple point? So the triple point is located right here. And if you see, it's about 10 to the negative first, maybe a little bit above. And then drop down here, and it looks like it would be a little bit above negative 200, maybe negative 180 or so. So negative 180 and about 10 to the negative first. Letter C. Is methane a solid, liquid, or gas at 1 atmosphere and 0 degrees Celsius? So 1 atmosphere and then 0 degrees Celsius is way over here. And you can see that we would definitely be in the gaseous phase. If solid methane at 1 atmosphere is heated while the pressure is held constant, will it melt or sublime? So if we're at 1 atmosphere pressure and 0 degrees Celsius, 1 atmosphere is heated while the pressure is held constant, will it melt or sublime? So if we go from here and we just say we're going to heat it, it's going to go from solid eventually to liquid and then eventually to gas. So it should undergo our melting, and then it should undergo boiling, and it should change through all 3 phases. All right, so those are some examples of the types of questions you should be able to answer by interpreting a phase diagram and becoming familiar just with what the lines are and where the solid, liquid, and gas piece are, and then knowing definitions like boiling point. That's when the vapor pressure is equal to the atmospheric pressure, can help you along the way in interpreting these diagrams and being able to tell where something is supercritical, a solid, a liquid, or a gas.